Hi guys, welcome to another video. Today we'll be doing the Leetcode daily challenge for 8th of July. As usual, I haven't seen the question, so let's approach this question together. We'll open the draw board just in case. Okay, online draw and auto draw. Yeah, let's see what this question is. Medium level. Finish. Okay, put a timer on it. Yeah. So we have n friends that are playing a game. They're sitting in a circle number from 1 to n. Okay. Moving clockwise from ith friend brings you to I plus 1, and moving clockwise n brings you to the first one. Got it. So start at the first one. Count the next 3 friends the clockwise, including the friend you started at. The counting graphs around the circle and may count some friends more than once. Okay. So you like repeat in a circle. The last friend you counted leaves the circle and loses the game. Okay. If there are still more than one friend in the circle, go back to step 2, starting from the friend immediately clockwise of the friend who just lost and repeat. Okay, else the last friend the circle wins. So let's draw this. Let's try to draw this and one. So n in the first case, n is 5 and k is 2. Okay, let's see. I'll draw the people first. 2, 3. Now this one is 4 and this one is 5. So the order in which we'll be going is so the oh oops. Yep. So this start with the first friend. Okay, so we start here. So case 2 and this one is to be counted. So 1, 2. What does it say? Including the counting graphs around the circle. We count from the last friend you counted leaves the circle. So I believe 2 should leave the circle. So 1, 2, 2 leaves, and then it starts here. 1, 2, 4 leaves, starts here. 1, 2, 1 leaves, starts on the next one, which is 3. 1, 2, 5 leaves, and 3 would be the winner. Yeah, that's correct. Nice. And 6k5. Let's try this one also. Uh, so n is 6. So 1, 2, 3, 4, 5. Let's put 6 here. And k is 5. Okay. Mm. So 1, 2, 3, 4. Okay, we start here. So 1, 2, 3, 4, 5. So this guy has to leave. Then this one would start 1, 2, 3, 4, 5. So this guy would leave. Again 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. C1 is the winner. Yep. Nice. Okay, so what can we do here? Follow up. Sec K and N are under 500. Can we do it in linear time with constant space? Okay, so I'm just trying to think what can we do. What is a good? Do we need a good data structure? Do we need maths here? Is there any pattern? So since we are removing the people from this circle, we'll need. I don't think we can directly do some math around this. So 5, because the circle first time would be of n n people, then n minus 1 people, then n minus 2 people. So the length of or the size of the circle would keep reducing. So that makes me think that we'll need to keep going around. What if? Okay. Yeah. So for n, we'll start at 1 and we can simply do 1 plus k. 1 plus k. So k is, let's say, 2. No, I think we should do the current minus 1. So like because we have to count this one, all like k would, let's say k is 2, so 1 plus 2 is 3. We don't want to go to 3. This one also has to be included. So 1 is the current. I'm not cutting this out because let's say it was 3. 3 plus, let's say k is 2. So 3 plus 2 is 5. But it should be 4. So 3 plus 2 minus 1. So this is our uh, new guy. Now the new guy has to, so this would, in a lot of cases, exceed the number of people. So we need to wrap this around in a circle. Okay, so let's say circle, we have something called a circle length. Circle length equals to n, and every time this would get reduced by 1. So in the beginning it is n. We start at 1, so start is 1. The new guy would be 1 plus k minus 1. So let's say in the second example, k was, okay, was k was 5, right? So let me try to go around this. So n is what? So circle length in this case would be 6, and k is 5, right? So we're sort of tracking the current friend that wherever we are. So from 1 we'll go to 1 plus 5 minus 1. So we'll go to 5. Right. So 5 is the guy who's going to get removed. Okay, so if 5 gets removed, we can start the next cycle from 6, but how would we track that 5 was removed? Yeah, that is a problem. That is a big problem. Like from 6, I'll again do plus 5, right? So 1, 2, 3, 4, 5. Let's say I have to move the circle. I'll end up counting these elements that were already removed. So I need to keep a track of the numbers that have been removed. And I do not want to do this linearly. Like from 6, I don't want to go to 1 and then 2 and then 3. That will be, the complexity would be n square, I believe. Let's see. So from 6, so I'll, in one round, I'll at max, oh, in one round at max, I'll do k hops, right? And I'll have to do k hops n times. So it is k into n. Because in every hop, one guy would get reduced, and if it is k, I'll keep doing k hops. So k times n. This is 10 power 2, so this should be 10 power 4. Not bad. This is doable. But again, even if we go linearly from 6, let's say I have to 1, let's say this one is already removed. 1, 2, I'll end up at 3. How do I? So I'll need to keep a track of the numbers that have been removed. That is not a good approach. And yeah, well, to keep a track of the numbers that have been removed, we'll also have to use another data structure like a set or something. And it's sort of, I want to target for a constant space. So what can we do? What can we do? Constant space. Can't use array also. Can't use a map also. Yeah, I'm sorry if this video becomes too long. I'll try to cut some parts or fast forward some bits. I don't want to waste your time, but I'm thinking what can we do here? So from 6, we want to go ahead and 1, 2, 3, 4, 5. We want to keep a track of the numbers that were removed. Don't want to do it. What if I have a variable? What would that tell me? If 3 was removed, the rank of these two would reduce. But if 6 was removed, the rank of no one would be reduced. What? 1, 2, 3. This solution is doable. Again, the solution with this complexity and some extra space is doable. Maybe we can, start with that, write that down, run it. But I'm thinking if we can directly think of something with constant space. So the main problem here is how to keep a track of numbers that have been removed. Sorry for the bad handwriting. Okay, how do we do this? How do we do this? One start at one. So let's say we're at one. We do one plus k minus one. We get a new guy. The problem is if friends in the middle were already removed, then we can't just jump from one to the new guy. We'll need to reduce those many people that have been removed from the circle. That is a major problem. Can't remove. Can't remove. Mm, what do we do? What do we do? I can't think of anything in constant space to keep a track of this. Can make a set. We can waste some space there, but if the question is saying it is possible to use constant space, what am I missing? What am I missing? All right. I think we should. I think I should code the one uh, with a set or something. I can think of the constant space approach later. Okay, so if we go about the steps, we'll have a current counter, which will tell us which friend is currently selected. Then hop to the next next one. This hop would be current plus k minus one, and this will be times. Keep a track of removed numbers. Uh, this we can do using a hash set, and then um, yeah, we just need to hop to the next one. Uh, Repeat till I guess hash set dot size is less than n minus one. Right. So let me create a hash set first. Uh, Removed. Yeah, I suggest whenever you're coding, like even just practicing, use good variable names. This practice helps a lot in the long run. I recently started doing this, and I we should do it from the beginning. So while remove dot size is less than n minus one, so we'll need int the current, which will be one, and k we have. So we'll need to number of hops. So I don't think we'll need to do this. Current plus k minus one is the expected new guy or new candidate. So for one it would be two, but the thing is once someone gets removed, so let's say we are at five. Okay, so one is okay. So we are at five, right? One, two, no. So oh, three. Correct. So at this stage, we're at 3 and everyone else is removed. So we'll do what? 3 plus 2 minus 1. So 3 plus 1, 4. We should be at 4, but there is no 4. Correct. So, yeah, I think instead of this, we just need to go ahead k minus 1 times because the current one is also counted. So we are at 3, and let's say only 2 are left. 3 would be 1. K minus 1 is what? 2. 2 minus 1, 1. So this is 1. We are at 3. We go to 4. 4 is not counted because it is in the removed hash set, and then we'll go to 5, which would be counted as 1, and that will it will get removed. Correct. Okay, so what we need to do is, mm, for we have to do this k times. Correct. Int hops equals to k minus 1. Now, while hops is greater than 0, you need to keep hopping to the next one. Okay, so we'll do curr plus, go to the next one. If not removed dot contains, so this is cur, we'll do the hops would be minus minus, otherwise there's no change to hops. Hops when it goes to 0. So finally we are at the element that has to be removed. So what we'll do is remove dot add hops. Correct. Now here one more problem, we're doing cur plus plus. This can overflow, so we need to account for that. So if cur equal n plus 1, cur equals to 1. So we're sort of resetting it, like it is said in the question. Where was this? Nth brings moving from nth friend brings you to the first friend. So if cur has reached n plus 1, means cur has to go to 1. Correct. Now we'll keep doing this while the size is this. Okay, there's another problem. Well, what is our answer? I don't want to reiterate and find the answer. So let's say we were going at 3 and I added this one, and at this steps we were at 5, right? Okay, one sec. So we remove this element. So 5 gets removed, and the next has to start at. We'll need to do this again. Okay, no, I'll need to leave it there also. Okay, see. Okay, so what we're basically doing is we are at inside this loop. We're doing hops is k minus 1. Mm-hmm. So we'll go to the next number. If the next number was not removed, we'll do hops minus minus. We do this till we, so we keep moving to the next one. We don't want to overflow, so we do this. Now we reach some number. Let's say we reach 1. We want to remove this number, so we remove this. Remove dot add. Oh, not hops. It is actually cur. Now since this one has been removed, we have to move to the next one. To prevent the overflow, we again have to do this. Now since we have moved to the next one, cur should contain the answer. So return cur. Mm, should be good to go. Let's check this. Where is, yeah. Interesting. I put 4. This is just 1. What am I doing wrong? Is less than n minus 1 when the size becomes. So let's say we were at 3 and we had 2. So from 3, hop is 1 again, right? So we'll go from 3 to 4. Is 4 removed? 4 dot remove dot contain. This is true. This is false. Nothing happens. Nothing happens. Again, cur plus plus, which is dot contains. Okay, 5. Okay, so remove dot contains 5, false, becomes true. Hops is 1 second. Cur plus plus we do. Let's say I'm at 5. I do plus plus 6. Right, it checks for 6. That is a problem. We have to check it every time we do the hop. Hmm, interesting. Mm-hmm. We start at 1. I'm getting 4 instead of how, how. I'm at 1. Hops is k minus 1. Okay, car is 1. And hops is what? 1. Every time it starts at 1 only. 1 is greater than 0. 1 becomes 2. Doesn't happen. 2 is not in this. Hops becomes 0. Go out. Remove dot add. 2. Go to 3. Doesn't happen. You go up from 3. Why did we go to? Oh yeah, we go to 3. Now from 3 we do plus to 4. Doesn't happen. 4 is not contained, so ops minus minus, then 4 gets removed. 4 is getting removed. What is the problem? I don't understand. It's keep a track of who is getting removed. So do the classic debugging statement. 2 is getting removed, 4 is getting removed, 1 is getting removed, 3 is getting removed. Wrong. 5 should get removed. 2 goes, 4 goes, 1 goes. Some mistake is there. Let's check this one. 5, 4, 3, 6, 1. Don't remember this one. What is the problem? Till on this one, till 1, everything is fine. 1 gets removed. Correct. Now we do car plus plus. So basically, it reaches 2. Actually, we need to end at a number which is not. Basically, yeah, I got the mistake. So we have removed this current number. Right now, we have to move to the next number, which is from where we need to start the counting. Okay, but if that number is removed, we can't technically start the counting there. So what I'm going to do is while. So basically, we have to do the cur plus plus remove dot add cur. Correct. I have this one has been like let's say I'm at 1, 1 has been removed. So while remove dot contains 1, 1 plus plus, which is 2. 2 is also this 3. Yeah. Oh, okay, okay. One more problem, slight problem. This has to be inside. So let me just do okay. What? Let me fix the indentation here. Remove the debug statement. Yeah, so just remember whenever you're doing car plus plus, this statement has to come right next to it because we don't want to cause overflow. That is one thing you need to take care of. We remove it and then we can return it. Yeah, let's see. Cool. But yeah, don't really like the. So yeah, if you just wanted to look at a solution, this is the first solution. I'm still going to spend some time trying to find a more optimized solution. So this one is using additional space, and the hops are also like sort of linear hops are there. Complexity is n into k. Uh, we want something better. So I'm going to spend some more time. Feel free to drop off. It's been 24 minutes. Not good. Okay, what can we do? Feeling like looking at the solution once. Yeah, I think it is a good time to take a look at at the solution, because there's no point of spending a lot of time on one question. So this is generally what I do: 20-30 minutes. I give a try. We do have some solution. I don't like the complexity. We should be able to do this in a better way. Let's take any random solution. Oh, interesting. Winner is 0. When no one is the winner, we start at I. I has to go to n. Every time winner is winner plus k plus. Hmm. Yeah, so I just found this solution. I think this is based on Josephus problem, and uh, the the approach is like pretty short. We did a lot of stuff here, but just found a very concise solution. If you look at this, it is called Josephus Problem. I'll leave a link to these articles in the description. I'm also going through this. So yeah, I think good find. I was not aware of something like this. And there's a diagram also: theorem for general Josephus problem. Nice. So yeah, do give this article a read. This is a good beginner solution, but yeah, of course, we want to try for the best solution. So yeah, I'll go through these and try to find the logic behind this one. Cool. Right. Thanks a lot for tuning in. Bye bye.